Hey guys, good evening everyone. Good evening. I'm hoping that it is live streamed and you are able to hear me out clearly. Good evening and warm welcome. Good evening and warm welcome everyone. So glad that you guys are here. Let's continue our journey with geometry reinforcement. I think we did a couple of lectures on this and let's continue on that. So before we do that, let me quickly introduce myself. I'm Belvi Srinivas. I've been working in this industry since 2007. That's about 14 years now. So in the 14 years, I did develop some acute skills to training the students in the place of QA, DI, and LR. I worked with various organizations in various capacities in the past. That's briefly about me, and you can kind of take a look at this just to understand what I have done a little bit in the past. Yeah. Uh, you guys can give me a brief understanding that it is live streamed and you're able to hear me out clearly. Yeah. Yeah, I think I'm audible. I think I'm audible. Yeah, let's get started. Let's get started. So that's briefly about me. That's briefly about me. Yes. So you are seeking a short discussion or a small counseling, you can join this Telegram group and you can work with me on this Telegram group. Any short discussions or short counseling needs, or it can be short queries or questions that needs to be addressed, you can put forth on this particular Telegram group. There are quite a few active students. Either they try to answer it or I will try to answer it. Someone will try to answer this, answer your, address your concerns. Yeah, that's briefly how we can kind of interface. Yeah, Sonakshi, good evening. Good evening. I'm hoping that all is good on the other side. Yeah. So before we get into the lecture, let me do quick short announcements. So here we go. So there are a few batches which are kind of launched today. So primarily they are aiming at CAT and OMETs 22. So if anybody looking for CAT 22 or OMETs 22, you can take a look at these batches. And there is a batch which started for SNAP, that's on 23rd of October. Of course, there are many other batches which kind of revision batches which started on the Plus platform, and these are some of the finest educators who are taking up dealing with these particular lectures. You can take a kind of look at them. And yes, that comes with certain subscription charges. A 6-month subscription costs you about 16,000. So, but you get 10% discount on this when you use any of the educator code, including my code, which is Belvi 100. Yeah, of course, you get facilities to look at SNAP course, IIFT course, ZAT course, many other courses which I've done in the past as well have been put up in the recorded format. You can also take a look at them. So all these are pretty structured courses. What I meant by structured courses is based on the various difficulty levels, the topics are kind of arranged and the different educators would have taken them up. And that is what you mean by learning in a much structured fashion based on your needs and requirements. Yeah, good evening, Keval. Good evening, Vibha. Good evening, guys. Yeah, so Iconic subscription comes with an additional feature of one-to-one interactions. You get a handful of one-to-one interactions with the mentors of your choice. You can request those request for one-to-one interactions, and in those one-to-one interactions, you can discuss various things. It can be test strategy, the score improvement. You can analyze your test along with the faculty member, or you can seek guidance on your preparation plan based on your SWOT strengths and weaknesses. You can also look for validation of your application forms where and when it is required. You can validate some of your responses for the interview questions. All of that, many more, many more. All these things can be discussed. So you have various plans, and on any plan that you buy, if you use the educator code, you get 10% discount on the subscription prices. So including mine, already you can use any of the educator plan, you get 10% discount on it. Yeah, till end of this particular month, that is till 31st of October. So there is an offer running, especially for the Iconic students. So you will get One-to-one sessions, generally one-to-one sessions in a 6 months plan is 25, but as an offer you are getting 35. All right, there are 35 one-to-one sessions in about 6 months, and it is 70 if it is 12 months. These are the features. Now you can set up, what it means by 35 is you can set up 35 meetings with your mentors in a 6 month span. You can avail 35 or 35 setups, 35 sit-ups, one-to-one kind of sit-ups. Yeah, that's briefly about the announcements for now, and let's continue our journey with geometry. Meanwhile, those who are here, you can quickly exchange your greetings. I can see Sonakshi here, Keval here, Vibha here, Vishal here, Isha here. Anybody else? Anybody else other than these folks? Anybody else on the meeting? Quickly put in your name out here so that I also kind of understand that okay, you are here with us today. Yep. Okay, this looks pretty much an active crowd out here. All right, fine. So let's come in here. I think yesterday we stopped after discussing this particular question. We said that hey, there were some parallel lines, and then we were talking about the basic proportionality theorem. Am I right? Am I right? This is what we were talking yesterday. This was one of the questions we did yesterday. Hi Rishabh, hello. Hello Abhishek. Yeah. This is what we were discussing last night. This is what one of the questions. I think with this discussion, we kind of winded up last night. And I'm not asking you to do once again. I'm just checking that, yes, this is where we kind of stopped. I'm trying to tell you that we were exploring basic proportionality theorem. We were exploring basic proportionality theorem. Right now, here we do another 2 CAT questions as it is, which appeared in CAT. This was one of the CAT questions. Why don't you take a look at this particular simple CAT question? Yeah, go ahead. This was one of the CAT questions. Take a look at this particular question and try to put in your answer based on the same theorem. Yeah, good evening Chinmay, good evening. Yeah, all of you guys, keep a book, keep a pen. Don't keep watching the screen. You don't learn anything like that. Keep a book, keep a pen, and whenever I'm giving time, please write it, because we are doing the reflexive style of teaching, right? Because we are doing a reinforcement lecture, not very basic one. So you take a look, and then I will come back. Then we will discuss the theorems if anything relevant out here. But we are packaging our learning so that it is effective at the end of the day. Yeah, go ahead, attack this CAT question. Keep a book, keep a pen, and try to work it out. Guys, are we live? What happened? I almost gave sufficient time. Okay, listen, all of you listen. This is a cold start problem. Listen, everybody listen. Do it with me. Everybody listen to this. Everybody listen to this. Okay, let me redraw this particular diagram. Yeah, what if I draw a diagram like this? Listen, guys, everybody listen first. Good. Yeah, listen here. I draw a diagram. Let me give some names here. Let me call this as C here. Let me call this as A on one side, and D on the other side. Okay, and between C and A, I will pick the midpoint of CA. Don't refer to that diagram. Listen to this blue diagram that I'm drawing. Here I have a triangle called CDA. There is a C, there is a D, and there is a A. I have a diagram CDA. I pick the midpoint. of this particular diagram, and let me name it as E. I just picked the midpoint of this particular diagram. I named it as E. All right. Yeah. From the midpoint of this particular diagram, I am drawing a line parallel to CD. I will draw a line parallel to CD. I draw a line parallel to CD. Okay. Now I just want to understand, let me call this particular point as F. I want to understand the ratio of DF is to FA. I want to understand the ratio of DF is to FA. Put it in the chat. Everybody put it in the chat. Look at this particular diagram. E is the midpoint. CDA is a triangle. E is the midpoint. All right, E is the midpoint of CA. From E, I draw a line parallel to CD. Now I am asking, let that point be F. I am asking you what is DF is to FA. What is DF is to FA? 1 is to 1. That is what exactly this particular diagram is. That is what exactly this particular diagram is. So this is where it is. Look at AE. Where is my AE here? This is my AE. AE is equal to EC. Exactly same diagram here. AE is equal to EC. Okay. So and this was the midpoint. E was the midpoint. From E you have drawn a line parallel to CD. You have drawn a line parallel to CD. CD was here. Here is CD. I have drawn a line parallel. Therefore you say that if this ratio given to me was 1 is to 1, then this particular ratio is also 1 is to 1. Clear, my friends? Are you able to visualize this now? Are you able to visualize this 1 is to 1 here? Knock off this diagram. This is irrelevant. Knock off this diagram. This is irrelevant. Remove this. Look at only the rest of the diagram. The rest of the diagram matches with this. Just that I rotated it a little bit here and there. Just that I rotated it. Then I am applying the basic proportionality theorem on this. What is this? Why did you answer this? Because you are aware of basic proportionality theorem. So you got that as 1 is to 1. Similarly, guys, did you all understand this? Say yes, no. Is this clear? Is this clear? You have to identify the same theorem in the larger perspective. That is it. Right? Yeah. Confirm. Quickly confirm. Understood, right? Keval understood, Sonakshi understood, Vibha understood, okay, Abhishek, Chinmay, very good, all right, yeah. So there we go, all right, now that is the point there. Now similarly, look from the other perspective, knock this off. Once you do that particular diagram, knock this off. This is not required. Let's say this is not required. This is not required, okay, here I am. Right, this knock the other side of the diagram. You knock the other side of the diagram, then you say that hey, D is the midpoint. From D you are joining a line to G which is parallel to, all right, which this particular line is parallel to B. This is parallel to B, and naturally you know that hey, this ratio was 1 is to 1. What was 1 is to 1? From A to D and then D to B is 1 is to 1. Why 1 is to 1? Because D is the midpoint of AB. From the midpoint, if you are joining a line and which becomes parallel to D, then this ratio also becomes 1 is to 1. This ratio also becomes 1 is to 1. Fair enough. So having understood this, put the numbers in perspective. You understood that, man, this is technically the midpoint of AD. The diagram is not clear. Technically F is the midpoint of AD. What is F? F is the midpoint. Technically F is the midpoint of AD. Similarly, G is the midpoint of AE. What is this G? G is the midpoint of AE. Courtesy basic proportionality theorem. That's it. Courtesy basic proportionality theorem. Technically you are trying to say that F is the midpoint of AD, G is the midpoint of this. Nothing but the length of AF is nothing but 1/4. All right, length of AF is 1/4 of 16, which becomes 4 because this is 4 units, this is 4 units, and this becomes 8 units because D is the median. Okay, similarly the other AC is 20 units. Therefore you say that hey, this is 5 units, this is 5 units, and the rest of this is going to be 10 units. And then you know that author is asking for the perimeter at AFG. One measurement is 4, one measurement is 5. He says that FG you cannot find out. Therefore he is supplying us FG is equal to 6. The perimeter is nothing but 4 plus 5 plus 6. 4 plus 5 plus 6. One measurement 4, one measurement 5, one measurement 6, which is nothing but 15 units. Right? So this is simply an application in CAT built purely on basic proportionality theorem. Clear? Shall we go to the next one? Shall we go on to the next one? All good so far? We'll go to the next one. Warm up is done. Yeah. Any doubts here? Anybody, any doubt, or are we good to go to the next? Any doubt, let me know right now. If there is a doubt, let me know. Yeah, no doubt. Good guys, very smart. That's nice. Pretty smart. Yeah. All right, let's move to the next one. Let's go to the next one. On this note, let's go to the next one. Now, here is another CAT question. There's another CAT question as it is. Another cat question. Another cat question. Applied. We are still discussing the same concept. I'm grouping things by concept so that we kind of revise that concept, right? And wherever possible, I'm taking the cat question as it is. Sometimes I'll tweak it so that it helps our learning. At times I tweak it just to enhance our learning. Yeah, let's go ahead. I will give about a minute's time, maybe minute or two, crack this. Nazia, answer options are there for this question. You have to match with answer options. If it is not matching, I don't know, because you gave some other number. Since it's a cat question as it is, so there are answer options. Not matching, I'm not sure. Maybe I might have done a typo error if not matching. Otherwise, one of them should match. Okay, so all right. So entire last few classes, I'm not sure whether I spoke about the construction. There is an important word. I'm telling you all right now. So why most of us are taking time to answer this question is we somewhere in our mind tend to believe that the given diagram is good enough, right? Given diagram is good enough. And we tend to forget the word construction. Okay, this is what the mistake we kind of do, because we kind of tend to forget the word called construction. What do we mean by construction? Construction means you draw a little further. You might draw a line, you might draw a circle, you might draw an arc. Doesn't matter. Generally, most of the constructions are straight lines, right? Constructions. Keep that in mind. Never tend to believe, never approach a question by thinking that the diagram is good enough, right? So that should not be the idea. Fine. At the end of it, you may really believe that, okay, at the end, it may realize that the given diagram is enough. But point is, whenever a diagram is given, if the given diagram, especially if you are drawing it, that's a different issue. When the words are given, you are drawing a diagram, naturally the whole thing is on your mind, therefore you would anyway draw it, right? So that is not a worry there. So but the point is, if the diagram is given, always say that, hey, the given diagram may not be enough, I might be asked to do some construction, it might be required to do a construction. That's the word you got to keep it in mind. That word you should keep it in mind. Just remember that construction is an important word. Given a diagram, not given, not diagram is not given, don't bother, because anyway the whole onus on you. Right from the scratch you have to draw the triangle and start creating it. All possibilities you will create, therefore that's not a worry. But the point is, whenever the diagram is given, that's when we get conned. Alright, that is when we get conned. Hey, we tend to believe that, mind tends to believe that it's enough. Okay, everything is given there, let me just figure it out, kind of. Okay, construction is the word I'm talking about. Drill it deep in your mind. Never believe that the given diagram is enough. Always open to the thought that I might have to draw some lines here and there. Fair enough. All right. So whenever you are doing a construction, what do you do? Whenever you draw a line, you draw from a point. All right, you draw from a point. I'm just telling you what your teachers have told in the high school. You take one of the given points, you will not create a new point. What are the points here? A is a point, B is a point, D is a point, C is a point, E is a point, M is a point. That's a point. The point is, okay, you take one of the given points itself. It is not that, no sir, I will start somewhere here, I will call it as N and do something there. That is very unlikely. That is very, very unlikely. Generally, the constructions are from the given point. Other one is, when you draw the line, either it is parallel, therefore from a given point, either you draw a line parallel to one of the existing lines or perpendicular to one of the existing lines. That is the idea there. More often than not, 90% of the time, more than 90%, right? So more than 90%, 92, 93, whatever it is, more than 90, almost 100% of the time, this is the moment of truth. What is it? We take one of the existing points and then we try to draw a line from that point, either parallel or perpendicular, or simply connect 2 points. That's it. Or simply connect 2 points. That's the easiest way. These are the three things that will happen. Pick 2 points, connect them, or pick a point, draw a line parallel to one of the given lines, or draw a line perpendicular to one of the given lines. Now, point is what? Hey, where is the question mark? Question mark is here. Question mark is here. AEEC. Therefore, your direction should be towards that side. Whatever the construction you do, don't try to do a construction on this side. Hey, I will do construction on this particular line called AB. Why you are going towards AB? When the question is about on the other side, don't try to do a construction some other side. Don't try to do a construction on this particular side. Tend to go towards that side. For example, Google Map said that, hey, you have to go towards northeast for your destination. Why you are driving south? When the direction is northeast, how is it to do with the south? Never go towards south. That's the whole point there. Your construction should be pointing towards this. Okay, why did I say so much about the construction? Because we came across this maybe for the first time in our learning. Therefore, I kind of made it very, very clear. Construction is between 2 points, or construction originates from a point and you will be drawing parallel, or you take a construction from a point and make it perpendicular, and all construction should be pointing towards the final end point, direction towards that. Good. If that is the case, right? So you will do a little bit of permutation, combination, all of which, then you realize that, hey, I will draw a line from here parallel to this line. I will draw a line from D parallel to this. Now you may wonder, how does this going to help us? So let's see that, hey, BD is to DC is 3 is to 4, BD is 3 and DC is 4. Therefore, I say that this is also 3x and 4x. How? Ignore this. Ignore this diagram. This diagram is not required to me. This diagram is not required. Just focus on the triangle BCE. Then you picked out a point E here and you have drawn a line parallel to this. Since this ratio is 3 is to 4, basic proportionality theorem, this ratio is also going to be 3 is to 4. Even that is going to be 3 is to 4. Okay, this 3 is to 4 is clear, my friends. So far it's clear. Give a quick understanding that 3 is to 4 is clear. Point is, I have to tend towards this direction. I'm trying to put the numbers in that direction. That's my point. We got to write the numbers in the required direction. Clear? 3 is to 4 is clear. This is given. This 3 is to 4 is given. This point was given. This is given. So what did I do? I projected it. I projected it on the final journey. I projected it towards my line, which is AC. I projected it. Good. All right. Now come to the rest of the portion. Now leave this portion. Leave this. Leave this portion. Now consider the rest of the portion. Okay. Leave this portion. Leave this. All this portion is not required. Leave this point of the portion. Focus only on the triangle here. Focus on the triangle. Focus on the triangle A, M, and E. A, D, and let me call this point as N. Focus on the triangle ADN. Focus on the triangle ADN. So in this particular triangle ADN, there is a point M, so which divides it. AM to MD is in the ratio 2 is to 1. This is in the ratio 2 is to 1. Now 1 corresponds to 3x, therefore 2 corresponds to 6x. Therefore 2 corresponds to 6x. 1 corresponds to, so look here, 1 corresponds to 3x because it's a 3x. Therefore 2 corresponds to 6x. Done. So therefore I'm ready with my numbers. All the numbers have been projected on the required side. Now I got to find out therefore what is AE. AE is symbolic of 6x. Therefore what is EC? EC is nothing but 3x and 4x put together, which becomes 7x. Therefore you say that the required ratio is 6 is to 7. Comfortable? Everybody clear about this? Everybody got this? What we are talking? Clear? Everybody clear on this? Construction is important out here. So you got to, whenever the figure is given, focus on construction. I already spoke enough about the construction. By now you should be clear. You should have recalled it. You should have recalled the full story of construction by your teachers. Yeah, good. All good on this question. All good on this particular question. How many of you remember mass point geometry? How many of you remember from your high school mass point geometry? There used to be a keyword called mass point geometry. Anybody remember here? Say yes if you remember. Concept of mass point geometry. Concept of mass point geometry. No idea, leave it. We'll discuss this later. We'll discuss this later. Yeah, don't worry. Anyway, for CAT, it is not very, very important. Not very, very important. Yeah, but then that is like learning differentiation. Right? Yeah, not the learning differentiation. It is kind of learning differentiation. When I want to do the maximum minimum of an equation, maximum minimum of a quadratic equation, cubic equation, whatever equation, one way is what? Differentiate and equate it to 0 faster way. Otherwise what? Otherwise you will try to adjust it to find the maximum or formula, all that stuff. Similarly, this is construction. If you don't want to construct, you use mass point geometry. No construction. No, yeah, I don't want to use any construction, etc., etc. Then you got to use the concept of mass point geometry. That is the point there. Now don't worry about it. So we don't have to study too much about it because that will take me 30 minutes to teach. No, not today. I will not take 30 minutes now because not very important from CAT per se. I don't feel it is very, very important. We don't have such luxury of time at this point in time. Because not very important as well. If it is required, we will see towards the end of it. Now don't bother too much or don't break your head too much behind that. I just made it a point. So if somebody knew, just like a calculus I knew, yeah, then you to calculate your maximum minima using calculus, why you want to adjust our formula, nothing is required for you. Likewise, from that perspective, I said, I don't know, don't bother. I don't know, don't bother. Right? If you are not aware of it, don't bother about it. All right, here we go to the next one. Switch in concept. Yeah, let's take a look at this question. Everybody take a look at this. I'm switching the concept now. I'm switching the concept. Basic proportionality theorem is over. Those applications should help us because one last thing I wanted to speak there was construction. We did that as well. Right, let's take a look at this question now. We got to compare these two triangles. All right. Yeah, I've switched the concept, right? Here I've switched the concept. Now I'm talking similar triangles, right? I'm talking similar triangles in this question. I've shifted the concept, right? I've shifted the concept. Actually, we are talking similar triangles. That's right? We shifted the concept to the similar triangle on this particular question. All right. The first point here is what? In a parallelogram, the opposite sides are equal. So now what are they saying that, hey, look at this first. AE is saying that 2x. Then here AE is to EB is 2x and this is 3x. Good. Then DF is to FC. Then this has to be 8y. I'm here DF and FC 8y and 7y. But the point is what? Hey, 2x plus 3x together is how much? 5x. 8y plus 7y is equal to what? 15y. Both should be equal. Both should be equal. 15y should be equal to 5x. There is no choice in the matter, right? Yeah. 5x should be equal to 15y. All right, they should be equal because we are talking about a parallelogram. All right, we are talking about a parallelogram. First and foremost thing is what? Opposite sides are equal. In a parallelogram, the opposite side measure equal, and there are many more properties. Let's not now get our study into parallelogram. When we do quadrilaterals, we will see about it. So for now, for at least elementary part, in a parallelogram, I know that opposite sides are parallel and equal. That much we know. Fair enough. Therefore, x is equal to what? 3y. If x is equal to 3y, please come back and substitute wherever x is there, substitute 3y in this particular place. Therefore you say that, hey, this measurement would now become 6y. Okay, so wherever x is there, put 3y there. Therefore, this measurement instead of 3x would now become 9y. All right, this would now become 9y. Good enough. All right, so now everything is in terms of y. Here, this is 8y, this is 7y, this is 9y, and this is 6y. Okay, everything is in terms of y now. All right, all in one particular measurement of unit. Now, so whenever it comes to similar triangles, listen, all right, properties, etc. What triggers? How do I understand that there may be similarity of triangles here? Couple of points is presence of parallel lines. Because first point is what? How on earth what triggers my mind? What triggers my thought to say that there is a similarity of triangles here? One, presence of parallel lines. Presence of parallel lines. You may presence of parallel lines may also mean that basic proportionality theorem, etc. It all depends on the shapes. But then presence of parallel lines. That's number one. Presence of common angle. These are the most important ones. Presence of common angle. You find a common angle in a diagram. We will see them as we go along. Presence of common angle. All right. And then presence of vertically opposite angles. It's not that everything should be available in the same diagram. Presence of vertically opposite angles. So these are the three important things. You may say that corresponding angles, yeah, important. Alternate angles, yeah, important. All these things. Basically, the angles are very, very important. What are the angles? Common angle, vertically opposite angles, corresponding angles, alternate angles. It is more driven by angles. It's a more an angular study. Of course, all right, now, so there may be presence of parallel lines, which can also trigger that particular thought. Now, having understood this, now I'm comparing which two triangles. Stay focused on those two triangles. I'm comparing these two triangles. Good. If I call this part as theta, then this is also theta. What is this? Presence of vertically opposite angles. Both are equal. Vertically opposite angles are equal. Good. And I have a parallel lines. The moment there is a parallel line, if I call this particular angle as P, then this angle also becomes P. Why P? Because they are alternate angles here. All right, they become alternate angles. Presence of parallel lines also gives me parallel lines. The presence of parallel lines also gives me alternate angles or corresponding angles. Things like that. Okay. What if I call this angle as Q? Then this also becomes Q. Therefore, you are saying that hey, three contours, three angles of a triangle are matching with another three angles. So therefore, shape remains same. Similarity means what? Shape is same. You can zoom the diagram, zoom in or zoom out, whatever you do. Shape remains same. No guarantee on the size. If size is also same, shape same, size same, then it becomes the congruency of triangles. Shape same implies that it's a similarity of triangles. How do you understand the shape is same? The contour should remain same. Contour is nothing but angles should remain same. Angles of one triangle should match with the angles of the other triangle. Good. The moment you read this, you understand this story will be kind of clear to you. Now you say that hey, whenever you are comparing in the similarity of triangles, you take one angle as the reference, and then you will find that already now if the reference of those can be compared. What I meant, see here, angle side opposite theta in one of the triangles and side opposite theta in the other triangle. Both are known. On one hand, I know this is 9y. On the other hand, I know it is 8y. So therefore it can be comparable to triangles. Now the sides relationship, because side opposite the same angle, it cannot happen that sir one time I will see the side opposite P, in the other diagram I will see side opposite Q. No, it cannot be seen as side opposite P and Q. That cannot be related. Side opposite same angles can be related. Good. So let me come to the triangle. All right, now let me come to the triangle EFG. What is the side opposite angle theta in triangle EGB? It is 9y. What is the side opposite triangle DGF? All right, now DGF. All right, here. All right, this is DGF, right? Now that is 8y. Good. So now these are the sides. Sides are unidimensional. But what I'm talking here, I'm talking about the area. Area means the square function. Area is a square function. From the similarity theory, all of you would know that area means it's a square function. Therefore, you say that this answer is, the ratio is 81:64. But had I asked, hey, what is the ratio of in radius of these two triangles? 9/8. Had I asked in the same question, tell me these two triangles, what is the in radius? 9/8. What is the perimeter? 9/8. What is the circumradius? 9/8. So you got to understand that what is the unit of measurement. If it is the unidirectional, no, it's a unidimensional, then you will retain the ratio as 9/8. Area, right? Its area is a square function. Therefore, you would have written this as 9 square by 8 square. See, all these are very basics of similarity of triangles. Comfortable, my friends? Everybody clear? Everybody clear with this basic example? All clear? First example on similarity, I spent some time. You all understood? All clear? Same for all linear parameters which are comparable. Even I can ask that, okay, what is the ratio of the medians, sum of the medians of both the triangles? It is also 9 by 8, K1. Even in this question, if I ask, tell me the ratio of the medians of all these triangles, it is 9 by 8. Ratio of altitudes, ratio of sum of altitudes, it is still 9 by 8. That's how the question can be complicated. I can ask ratio of the altitudes. They think that, okay, I have to do some terrible work on this to find the ratio of the altitudes, ratio of sum of altitudes. No, ratio of sum of altitudes is nothing but the ratio of the sides, ratio of one of the sides. Right? Yeah, good. That's the point there. That's how they can complicate it. They can complicate that particular language a little bit. All right, so here we come. Yeah, another beautiful cat question. Try this. Try this. Everybody take a minute or two and try this beautiful question. Yeah, now at least I conditioned your mind. You know that I'm talking similarity. Knowing I'm talking similarity, tackle it. Because without knowing I'm talking similarity means another stimulus in your mind. First, you should understand that similarity is required. But you know that we are kind of talking somewhere closer to similarity for next some moments. Okay, all right. So let us exercise. Let us exercise our similarity out here. Then we will see how we could have done this little faster and better as we go along. And after that, wherever there is a better way to do it, I will not tell that, okay, proofs can come by similarity, but we will not be dealing with it. Just as a matter of practice, since it's our second question, for the time being, ignore these lines. Listen, guys, everybody listen. For the time being, ignore these lines. Just focus on the rest of the lines. In the sense, I just focus only on this diagram. That's it. This is all you got to see for the time being. This is A here, this is B here, this is C here, this is D here, in which these two lines are parallel. This is all I want you to see. All right. Now, having seen this, so you call this as theta, then vertically opposite angle theta. Assume that the rest of the diagram does not exist. What I meant is, hey, this part of the diagram does not exist. For the time being, this part of the diagram does not exist. There is a theta and there is a theta. All right. What if I call this angle as P? Then this angle becomes P. Why? Because these are alternate angles. All right. Yeah, what if I call this particular one as Q? Then I got to call this as Q. Why? Because these are the vertically opposite angles. Okay. So therefore you say that these two triangles are similar. So therefore you understand that, hey, this triangle is similar to this particular triangle because angles of one triangle are matching with the angles of the other triangle. Fair enough. Okay, so let's try and understand what is this particular side. Therefore this particular side AB is 10 units. What is the other side? Given it is 15 units. It's given 10 and 15 is given to me. So from here you say that, hey, sides opposite theta. Now look at this. This side is side opposite the same angle theta. This also side opposite the same angle theta. And hence I say that, hey, in these two triangles the ratio of the sides will be 2 by 3. What is 2 by 3? 10 by 15. All the sides will be in the ratio 2:3. Fair enough. If that is the case, hey, what is the side opposite Q here? The side opposite Q will be of the form 2A. Side opposite 2A. What is the side opposite 2 here? All right, now this will be of the form 3A. This would be of the form 3A. You may say that, sir, what if I take P as the reference. No worries. If you take P as the reference, you would have written here P as the reference. You will say that, hey, this would be 2B, and P as the reference, you would have written this as 3B. 2 and 3. Why? Because the ratio of the sides are 2:3. This is the very basic formation of similarity of triangles. My point is what? Given any triangle, first you should be able to identify certain similarity, because after some time what we are going to do, we are going to squeeze these things into circles, right? So we have not introduced circle set. So we are still keeping away the circles. The moment circle comes inside and we have to try to look at some triangle inside and the similarity inside, oh, it is going to be nightmarish if I am not able to see on this without circles. Circles come and they complicate the whole scenario. That's what we are going to look in the future. That's what we are going to look into the future. So first I need to have the eye to visualize where are the similarities to start with, because that's very important. Similarities, pretty important concept there. Good. Okay. So far is it good? So far is it good, everyone? Are you able to see these similar triangles and you understood how I wrote those values? Quick. Because first thing is to learn to visualize where are similarities. We should be able to kind of visualize them, see them. Vertically opposite angles, parallel lines. There were parallel lines here. AB and CD were parallel, and there were vertically opposite angles. I should be able to visualize that first. That's most important. That is the most important element. Yeah, all good so far? Yeah, nice. Okay, now, so remove this. I will come to the true sense. Now what I'll do is, hey, I don't need so much of data. It's a overcrowding of the data. I've crowded this particular data. I will say that, hey, all this is not required. Too much overcrowded. All right. Okay, so I have so much of data. Fine. Are we connected back? There was a brief disconnection. Are we connected back? There was a brief disconnection. The OBS, are we back? Quickly confirm. Yeah. Yeah, nice. All right. Yeah. Okay. Now listen. Yeah, good. Yeah, that's enough. Listen. Now what I do, I will knock off this diagram, chop this off. I don't need this. I'm chopping this off. I'm chopping this portion of the diagram. I will retain the dimension of this line. Only dimension of this line. This is 3A units. I retain the dimension of this line. That is 2A units. Totally it is 5A units. I chopped off the top. I don't need this. Okay. I even don't need this particular line. This line is also erased. This line is also erased. Now I have this line which is parallel, in the sense I am now seeing this particular diagram like this. This is all I'm seeing. I have a line EF here. Hey, this line is AB. This is AB. Listen to this carefully. And you have EF, which is parallel to AB. And I know this dimension is 2A units. This dimension is 3A units. And I know that total is nothing but 5A units. Total is nothing but 5A units. Therefore, I know that, okay. Therefore, from there we know that. Right, from there we can say that this is the units. So by the basic proportionality theorem, this 3A I can write it here. This is 5A, which I can write it here 5A. But what is the value of 5A? 10 units. 5A corresponds to 10 units. Therefore 3A corresponds to how many units? 3A corresponds to 6 units. I can again speak similarity here, but it is not required. We kind of already know the basic proportionality theorem. If this is given to me as 3A, here this is given to me as 3A and 2A, I know that a total length of this triangle is 5A. Therefore this will be a function of 5A. This would be a function of 3A, and you can kind of write it out there. Is this clear so far? Is this clear so far? Therefore answer is 6. Is this clear? Is this clear? I applied basic proportionality theorem here, which is a subset of similarity of triangles, which is also a subset of similarity of triangles, in the sense once I see this 2A 3A, I know the answer. I immediately know the answer. That's my point. I immediately know the answer. No big deal. I immediately know the answer. Right? Yeah. Keval, don't worry. With practice, you should be able to visualize. Right? And similarity is one of these important concepts in triangles. Okay, don't worry. All right, now once you start doing it, you will be able to visualize this. It's just a matter of practice. Is it out of form or in form? Sometimes when you are out of form, simple questions appear complex. When you are in the form, everything comes out, or you will be able to see them. Just you should be in touch. Therefore, we say that revisions are important, right? You got to revise so that you stay abreast with the subject. Okay, good. All right, let's come back to this. Now, this is very popular question. This is pretty popular question, and whatever we discussed so far can also be worked out as. Now, this is a very popular question. This crisscross mechanism. See here how this construction has come in the picture. Everybody listen to me. This kind of construction, how this construction has come. There is a baseline, and author has picked up two parallel lines. two parallel lines. He took one base and then he built two parallel lines on this. He built two parallel lines on this. From there he went on to connect them. He went on to connect the opposite ends. Okay, he said that let this dimension be A units, let this dimension be B units, A units and B units. Now wherever they got connected, he squeezes another line parallel to the given two lines. Let's say that the given lines were AB and CD, and he squeezes another line parallel to them, between that called as EF. Now EF is nothing but semi-harmonic mean of the other two numbers, this number and this number. So what is EF? EF is nothing but EF is equal to semi-harmonic mean, semi-perimeter types, semi-harmonic mean of A comma B. What do you mean by harmonic mean of A comma B? 2AB divided by A plus B. We all know. Okay, what do you mean by semi-harmonic mean? Half of it. Therefore half can be cancelled. You can rewrite this as AB divided by A plus B. This is what is nothing but the measurement of EF. So this is all. This is once you realize it is not at the expense of not able to see where are the similar triangles. Yeah, you first see similar triangles. That is how we prepare ourselves for the bigger battle, because tomorrow circles will come. Inside the circle you will have some triangle will be coming outside. I should find some similarity there. If I lose my eye for similarity, then God help us, right? First let us have it, and then there are multiple ways to deal with it, because some questions are pretty standard in nature. We know that hey, this is one of the very standard question. I can use the concept of semi-harmonic mean in this kind of standard construction. This kind of standard construction I can do it. Therefore, looking at this particular question, had I known that standard construction, I know one side is 10, I know one side is 10, the other side is 15. I could have written my answer is equal to 10 into 15 divided by 10 plus 15. This is the effort it could have taken to answer this particular question if I were aware of this semi-harmonic mean part. Comfortable? All good? All good? Don't learn this semi-harmonic mean at the expense of not seeing the similar triangles. First see them and then learn all this. Good? Yeah, proof is pure geometry. You can use that. Similar triangles itself is the proof. That's how you do them. Yep. Okay, all right. Shall we go together? Shall we go further? Shall we go further on this? Very basic question. Go ahead. I expect that everybody answers this question. Again, I told you when to use this. Again, you are asking this. This is the construction, man. I told you, right? Only for this kind of diagram you can use. I told the full story. How to identify when to use it only, I said. This is the story, no? This is the full story, right? This is the complete story behind it. This is the concept. This is when you use. When to use means what? This is the standard diagram. Whenever this diagram comes, you can use. Otherwise, you can't use. Yeah? All right, answer this. Everybody answer this. It shouldn't take more than a minute. This is one of the standard questions. No maxima minima, static question. On this, maximas minimas can be asked, but this is pretty standard question. Go ahead. Yeah, everybody answer. I expect answer from everyone. Yeah, well guys, let's do this together. Shall we do this together? Let me take that's okay. One thing I don't know, is my assumption right? In general, I'm not talking anybody in particular. In general, it appears to me that your performance on this, looking at this, you are struggling a little bit in geometry. You are yet to complete your portion on geometry, or you have been struggling a little bit in geometry. You kind of did it once and been struggling. Put it in the chat. It appears to me like that. It appears to me like that. Answer this question. Forget this question. Answer my question. Is it that you guys are struggling a little bit in geometry? Because your reflex actions have been not very encouraging since the time I started. Yeah, you are reflexing. I'm talking as a group. I'm not talking as an individual. As a group, some of you can respond to this. Is that true? My understanding is true, or am I giving less time? I don't know. I feel it is appropriate. Right now only. Present situation. That's right, Keval. Present situation only. Future will change. Future would be better. No doubt about it. Both your future, my future, everybody's future would be better. No doubt. I'm not questioning it. Only the present state situation of learning I am talking at this point in time. Yeah. Okay. Chinmay says basics are done, not gone to the depth. All right. Okay. All right. Only 3, is it? Rest of you all, then why you are not answering others? You wanted a little more time? Should I give a little more time for the questions maybe? Let's try that. Okay. Then the understanding is little more time kind of. All right. Yeah. All right, fine. Let's take a look at this. Listen, everybody listen here. Everybody listen. Let's do this question. He wants the side of the square, right? Yeah. That's right, Rashav. That's right. So that's how I'm drawing a little bit conclusion because it's my 3rd lecture. Therefore, in the first 1 or 2 lectures, I cannot. So, but as we go along somewhere, so that helps me to modulate, select my questions, select the themes. That's all. Now, the point is, when I'm saying this, there is a bigger thought behind my mind, right? So, how should I take you from here? How should I take this group from here? That's the plan I will be thinking about. It is not about. So, when I ask these questions, there will be always a bigger picture behind it. So there will be something useful to me to plan my lectures. That is how I speak. Therefore, I'll wait for your answers sometimes. Okay? Yeah. All right, fine. Otherwise, I'll be working on assumptions, right? So 1 or 2 lectures, I can work on assumptions. After that, we can get to a little bit of specifics based on feedback. Okay, good. Coming back to this, listen, this is the square. This is the square. Let me say that the side of the square is A. Therefore, this is also A. And hence, you say that, hey, what is AB? AB is equal to 15. Therefore, this is 8. If this is A, then this is going to be 8 minus A. This is going to be 8 minus A. What is A? BF, that is the side of the square, which I am calling it as A. BF is equal to A. Therefore, what is FC? FC is nothing but 8 minus A. All right. Okay, this is the diagram. Whatever is given to me, I represented it. What I called A is nothing but the side of the triangle. Hey, man, where are the similarity here? Now, this is the similarity. Let me call this particular one as theta. First, focus on the bigger triangle. Only focus on the bigger triangle ABC. In triangle ABC, I am calling this angle is theta, and let me call this as theta dash. What do you mean by theta dash? They are complementary angle. Theta dash plus theta is equal to 90 degree. When I write it as a dash, it is the complement. If I write double dash, some people write like this: theta plus theta double dash means 180 degree. Supplementary angles. Okay, these are some notations, local notations, locally. Hereafter, when I write a single dash, understand that they are complementary angles, which means they add up to 90. If I write a double dash somewhere hereafter, treat that, okay, I am talking about supplementary angles between us. This is between us some notation, so that already it becomes a lot easier for us to navigate from here. Fair enough. Theta and theta dash, therefore I wrote theta there, and here it is going to be theta dash. I replicated those angles, theta here, theta dash here, 90 here, 90 here. That is given figure. All right, that is what has been said to me. Fair enough. So that is said to me. Now look, where is the similar triangle here, man? Okay, this is also 90 degree. All right, now look at the triangle EFC. All of you look at the triangle EFC. In triangle EFC, EFC is also a similar triangle. Why? Because if this is theta dash and this is 90, naturally the remaining angle has to be theta. You may wonder, sir, I will show you one more similar triangle. Sure, you may show this is 90, this is theta, but all that complete, how many are there is not important to me, right? Yeah. So how many are there is not important to me. What is relevant is important to me. That's it. Okay. Once I found my relevancy, apply this on the, go to the similar triangle, larger similar triangle, this one. In the larger similar triangle ABC, the side opposite theta dash and 90. The phrase I'm using is side opposite. Side opposite theta is 8 units. Side opposite theta dash is 15 units. Side opposite 90 would be 17 units. 8, 15, 17. All it is nothing but the 8, 15, 17 is a Pythagorean triplet. Fair enough, because 8 is given to me. This side was 8 and the other side was 15. 15, therefore this is going to be 17. Good. So we got these particular sides. In the sense, whatever the triangle you form whose angles are theta, theta dash and 90, the ratio of the sides is 8, 15 and 17. That is it. Ratio of the sides opposite these angles are going to be 8, 15 and 17. That is my point. Okay, man. So let me come to this smaller piece of the triangle then. Let me come to this smaller piece of the triangle. What do I know? I know angle opposite theta dash here. I know angle opposite theta dash. What is angle opposite theta dash? A. Therefore, I will write A, which means 15 corresponds to A. Very good. Therefore, 8 corresponds to how much? This is something like this. 15 implies A. 8 implies how much? 8 implies how much? 8 implies 8 by 15A. 8 implies 8 by 15A. What is 8 by 15A? This particular side. All right, now side opposite theta is this. This side is 8 by 15A. This is 8 by 15A. But what did you say earlier? Hey, what did I say earlier is that this side can also be called as 8 minus A. If you can call it as 8 minus A, then these should be equal. Equate them. Therefore, you say that, hey, 8 minus A is also equal to 8 by 15A. That is what you are trying to say. Therefore, you say that 15 plus 8, all it, which is nothing but 23A is also equal to 15 into 8. That's 120. Therefore, A is equal to 120 divided by 23. This is the side of the square. Very, very simple question on similarity of triangles. Can you all confirm that you understood this? This piece of information is clear. If 3 sides are in a particular ratio, any triangle with the same angles, the ratio of sides will match. That's it. The ratio of sides will match. Any triangle, if I know the triangles are similar, if I know the ratio of sides opposite certain set of angles for one triangle, any triangle whose angles are theta, theta dash 90, the sides will be in the same ratio. Point clear? Point clear? Point clear? Yeah. Good. All right. Go ahead, answer this question, cat question. Answer this now. Everybody answer this. Everybody is in a position now. Go ahead, answer this question. That sends me some confidence. Go ahead, guys. Everybody go ahead. Yeah, I'm giving sufficient time. No complaints. I'm giving sufficient time. Answer this. Hey, simple questions on cat. I'm not still mixing circles. I will make after the next lecture. That's when the beauty comes in the picture. Right? There are no curves here, only lines. For the last 3 days, we are discussing only lines. No curve at all. Yeah, Rishabh, that is problem of plenty. 2 smaller triangles are similar. Yeah, take whatever is required. Take how much ever required. There may be many similar triangles. Take what is required for you and work with that. All may not be required. It will be problem of plenty. Too many things may not be required. What happened is the calculation taking time here. Very similar. Let's say that, okay, my bigger triangle. Okay, do it with me. Do it with me, guys. Do it with me. Yeah, so here is theta. Okay, if I give a little more time, you will all close it. That's not a worry. Let me call this as theta dash. There is a theta, there is a theta dash, and there is a 90. Okay, I'm calling it one as theta, one of them as theta dash, and I'm calling it as 90. Side opposite, okay, let me call this itself theta and theta dash. Side opposite theta, 8 units. I'm talking in terms of larger triangle ABC. Side opposite theta 8, side opposite theta dash here. Side opposite theta dash means this whole stuff, which is given to me as 15. It is given, all right, that's given to me as 15. Okay, 15. Therefore side opposite 90 is going to be 17. Good. So therefore this becomes the ratio of the sides of the triangle whose angles are this. Ratio of the opposite sides of these particular angles would look something like this to me. Okay, there are multiple ways to approach this particular question. You can take anything as a reference. Let me take, all right, now the bottom side here as the reference. Let me work on the bottom line. Hey, what is the other way to work on this question? You can work on this particular line. These are the two most suitable ones. You may say that no sir, I want to complicate a little bit. You can work on this line also. There are three ways to approach this question. You can take any of the boundary lines and work. Bottom is easy, therefore I'm taking bottom here. No, any other thing is also fair enough. Okay, if I'm taking bottom as the reference, so this is one case I will take. Hey, this side is A, let's say, then this side is also A. Okay, first let me take this triangle. Listen to me, I'm taking the triangle FGC. I'm taking the triangle FGC. What I mean by saying that the bottom as the reference, I'm interested in this and this. What is this plus this? I'm saying this, I will get a value called X here, I'll get a value called Y here. What does it mean? X plus Y is equal to 8 units, right? X plus Y is equal to 8 units, which is given to me. I'm not saying that, hey, where it is given X plus Y is equal to 8, it is given the length of BC is equal to 8. I am saying that it is broken into two pieces. One piece is called as X, another piece is called as Y. I am interested in what is X and what is Y. Together it will be equal to, all it together, that is going to be 8. That is one way. You may say that no sir, I will call this as X, I'm fine. So therefore I will call this as 8 minus X. Fair enough, proceed. You will still get the answer. Either ways it is fine, which way you work it out. Fine, let me call it as X for the time being. Let me call it as Y for the time being. Good enough. So now let me go to triangles, what I circled here. What I circled? G, F and C. Let me quickly go to triangle GFC. What I know, I already know this A. Don't disturb this. Side opposite theta dash is equal to A. Write it here. Therefore, you are trying to say that 15 corresponds to A. If 15 corresponds to A, to find out what is 8 corresponds to, find out what is 17 corresponds to. Good. Hey, what do you mean by that? Hey, where is theta here? This is theta. What is this? This is 90. Good. Therefore, if 15 corresponds to A, then 17 corresponds to 17 by 15A. 17 by 15A. What is this? 8 corresponds to 8 by 15A. Good enough. So where are these dimensions? I am interested in this dimension. Side opposite 90 is my Y. I will write that particular value. I am interested in this. What is side opposite of this? 17 by 15A. Okay, I got this particular piece. Now what do you do? Now go to other side of the triangle here. Now go to this triangle. All right, this triangle. So which is the triangle? I'm highlighting it by circle. Now I'm saying that go to triangle D, B and G. Go to triangle D, B and G. Go to that particular triangle. So now where are these particular angles? You say that, hey, this is theta. How do you know this is theta? Corresponding angle, man. If this is theta, then this is also theta. Why? Because this line is parallel to this particular line. They are corresponding angles. Fair enough, they are corresponding angles. Therefore this is theta. Therefore this is going to be theta dash. What do I know? I know that side opposite 90 is called as A. I'm putting an arrow there. Side opposite 90 has become A here. Okay, side opposite 90 means 17 corresponds to A. Very good. Then what does 15 corresponds to? 15 by 17A. Very good. What does 8 corresponds to then? 8 by 17A. Nice. So what I want out of this? I want out of this what is the side opposite theta. Out of this I want what is side opposite theta, which becomes my X. Okay, what is side opposite theta? 8 by 17A. Good. This is 8 by 17A. Now you are trying to say that X plus Y is equal to 8 means 8 by 17A plus 17 by 15A is equal to 8. From here I got to take the LCMs, etc., and then figure out what is the value of A. Comfortable? You kind of understood this? Understood this? Understood this? Yeah, we'll have calculators, all of that. That's the next issue. But did you understand how to put the numbers to perspective? That's important for me. You got how to put the numbers to perspective. That's important. That is important. You got that point, everybody? Very simple. What did you do? You just applied the similarity of triangles 2 times and calculated. That's all the effort it takes. That's all the effort it takes. Yeah. Clear? Guys, give a quick confirmation. Are you clear what I'm saying? You got the approach. Calculation later. If you want calculation, we can do calculation. No big deal about it. We know what is 17 square. We know what is 15 into 8. All that can be done. But you got the bottom line. Yeah. Good. Nice. All right. All right. All right. We'll go to the next one. We'll go to the next one. We can calculate. If anybody wants to calculate, give the full answer here. What is A? Give full answer in fraction form. Why don't you give this in the fraction form? Quickly give the full answer. One of you type it. Whoever is quick in calculation, type this. Put the answer 15 into 8. Don't give me any decimals or something. Put in the fraction form. It shouldn't take much time. 15 into 8 on one hand. Right, that is 120 plus 17 square 289 divided by 17 and 15, that is 225 plus 30, that is nothing but 255. Yeah, 255 times of A is equal to 8. Then put it to perspective, you will get your answer. Fast. Who's giving the answer? Yeah, that's right. That's right, Sonakshi. Therefore, A is equal to, very nice cable, 2040 by 409. Makes sense. Makes sense. All right. Yeah. So that's all the effort it takes. That's my point is, hey, what if this question comes in IIFT? You got to write this, right? You got to write this if this question comes in IIFT, because comes in CAT is a different issue. You have a calculator. What if this comes in IIFT? If it comes in IIFT, you got to do this. Therefore, I said that don't resent from calculating. Sometimes we don't do that in the class because we'll save the time for the next question. But the point is, don't resent. These calculations are fine. All you have is the tables of 17s and 15s and 8s. We can't resent such calculations, right? Good. Okay, they're pretty favorable calculation. That's my point. All right, so here we come to the next one. Okay, before we do the next one, let me leave you with certain thought there. Important. Yeah, let me leave you with this thought so that next class I can capitalize on this. Yep. Yeah, that is fine, Rishabh. That's fine. Yeah, take a look at this. Now I've squeezed in. Yeah, right, Nazia. Now I've squeezed in an important property because I'm going to capitalize on this property in the coming lectures. Of course, similar triangles for me is not yet complete. Still a portion is left, but I want to squeeze in a little more here. Of course, this is a similar triangles only. So try it for a couple of minutes, everyone. Very important property you would have learned in the high school. A very important one. There is a very important property. That's what I wanted you to recall. Of course, the proof is similarity. Apply similarity, you will get the answers. Then recall your concept. Apply similarity and answer, guys. You should get this answer by now. This is one similar triangle. This is another similar triangle. Apply it, you will get the answer. Right, good. Okay, if you apply on these two triangles, similarity on this and similarity on this, you get it. Okay, good, very good. Yeah, this takes about 1.5 to 2 minutes time. That's right. Now listen to me. Everybody listen to me here. Everybody listen to me. Okay, listen, everybody listen. Important concept I'm telling. So what you would have learned when we are transition, how do you mix the similarity and right angle? Because we were having similarity with right angle for quite some time now. It is not that this is the only question you're doing. Hey, I squeezed in a square inside this. I squeezed in a square inside this. Oh, we used there. Okay, then I squeezed in a square like this. So there also we did that. So in the sense, so this reminded me that hey, there is one important thing, all at which we should not be overlooking. Fair enough. Take a look at this. So what we do learn here by using similarity, if this triangle is ABC and if you drop a perpendicular onto hypotenuse and call this particular point as D, so now you say that hey, this is my reference, this side is my reference. You will take A as your reference point. Listen, A as your reference point. First look on this particular side, that is AB is one of the sides. By similarity you can prove that AB square is also equal to, from here, AD, because D is the block here, AB square is equal to AD into AC. If you cross that block, you will go till there, AC. That is one. A as the reference point, AB square. What is AB here? Side. Alright, this you are talking as the side. The square of the side, A as the reference point. Look at three dimensions that you have. What is the dimension? AB is one dimension, AD is another dimension, AC is another dimension. Only three measurements can be done from A. If you are at A, you can tell me the length of AB, you can tell me the length of AD, you can tell me the length of AC. How these three are connected? AB square is equal to AD into AC. That is one property, very important. Alright, in the sense where these proofs are coming from, similarity, whatever we learned. Because why I was talking about this, we already learned, did two questions on similarity. It should have triggered when you looked at those particular question. Hey, by any chance am I using this here? Something like that should have triggered your thought. That is my point. Something like that might have triggered, might not have triggered as well. I'm not guaranteeing it on it. Fair enough. Let's come to the next one. Okay, coming to this. So what if I take B as my reference point? What if I see here? See, so both ends of the hypotenuse. First you took A as the reference point, done with it. Other side of the hypotenuse you take C as the reference point. C as the reference point. So what are the measurements you can do? CB is a side. Okay, therefore CB square, a side square. CB square is equal to CD into CA. CD into CA. This is something your school teachers, high school teachers would have very much drilled. Okay, that's all the sides. That's all the sides I have. There is nothing. You may say that no, sir, I will now take AC square. Doesn't work. All right, no, that's not the idea here. So these are the two sides, AB or CB. These are the two sides. So the next one is the height side. This is height, BD. Next comes is the height. How height is related? You say that hey, BD square is equal to, that is D as the reference point. All references are on the hypotenuse. Now look at that. What are the three references? A was a reference, number one, and you wrote one formula. C as the reference, you wrote the second formula. Third one, take D as the reference. Okay, therefore DB square, that is the height. This height I'm talking about. DB square is equal to DA. From D you go towards A, and from D you come towards C. D into C. Now I was actually talking about this. After doing this, I allowed you 2 minutes. Reason being, after writing, at least try and realize these three important things what your teachers have said in the high school in the geometry part. Okay, coming back to this. Now in this question, this was one of the CAT questions. After looking at this question, had you realized this particular parameter, you say that man, I would have taken D as the reference here. One side I have 7 units, the other side I have 5 units. Therefore I would have applied it here. DB square is equal to DB square. I know the value of DA 7. I know the value of DC 5. Therefore DB square is equal to 35. Therefore DB is equal to under root of 35. That's it. This is a mental question. Could be done in the mind, provided you are mindful about these three important things where you learnt about the similar triangles and the right angle triangle put together. Making sense? Are you all learning something? Clear about this recall? As a part of reinforcement, you got to recall certain things you learnt. You got to recall certain things you learnt. Or you are learning, whatever it is. Learning or already learned, doesn't matter. These are all very important facets. Yep, great. All right. Oh, there is a lot to talk. There is a lot to talk. I don't know. I only spoke 50% of what I wanted to tell today. So because I said somewhere your reflex actions were little slower than I expected, especially on geometry. So do a little bit of work on geometry, all right, so that you get a little bit of form out there, right? Yeah, a little bit of form out there. So then we will be able to move a little faster. What I'm asking you to do is, as we are trying to do some geometry reinforcement, spend every day maybe about 60 to 90 minutes on geometry. Just spend this time, so that all right, so you kind of do something, the warm up is good, so that when we are trying to do the reinforcement, it becomes little better. All right, it's the reinforcement, because as I get into the circles, we don't want to be very slow. All right, being too slow doesn't make sense. That's the whole idea there. Okay, so I will stop here for the time being, because it's almost about 11:15 by my watch, so we will kind of stop it around here. So what is coming up next, let me quickly tell you. So what we are doing next, before that, let me do one quick announcements. You guys might have doubts. Some of the doubts you some of the doubts you kind of put it on my on the Telegram link as well. Nothing wrong, do that. Also, there is another feature Unacademy has it. If you just update your app right on the dashboard, you kind of see that ask a doubt feature. So it's a very self-navigating. Once you click on that, it will just take you to the next window, and then grab that particular question which is your doubt, and then send it. All at once you send it. Yeah, all this is self-explanatory steps. I don't see a rocket science in this. Just do that. Probably all right, one of them will quickly get back to you on the responses, because at this point in time, from your mocks, etc., you might get a lot of doubts out there, right? So that's what you kind of do there. Yes, there are certain mocks. I did the analysis of 2 of these particular mocks as well, which was held on 17th and 24th. You can still take them, I guess, but you may not get the all India ranks, etc., but you might be able to still take, I guess. Other one is coming on this particular Sunday, 31st, 12:30 to 2:30. If you want to try it, you can try this, and you can park one of your mocks for Tuesday or something like that, because starting this particular week, all of you try and write 3 mocks per week. So because you may be already, you'll still get sufficient time for revision through mocks itself. You can kind of do quite a bit of revision. It happens revision in your mind. So try and increase it for the next 3 weeks, 3 mocks, and decide how you want to do the final week. Sometimes some people want to keep the final week little lighter. They want to keep the final week little lighter. Keep it little lighter, or some people want to go little heavier towards the exam. That is very individualistic, how you have been right from your childhood days. Carry with that momentum. There is nothing wrong. Different kids are different. So because you behave differently, your friends in the high school behave differently, college behave differently, like that. So we all have different ways of studying. There is nothing right or wrong about it, but there are certain common things. Hey, increase the mocks, increase the mock attempt if you are serious about your exam. For the next 3 weeks, you increase it. Final week, that's your choice, because some people want to go lighter, some people want to go heavier. There is nothing right or wrong about it. What suits you, you do it. What has suited you in the past, you continue to do it, right? That's what you kind of do there. Yes, so wherever, all right, if there is a code that is required, I am encouraging you to use my code. You can use my code to do that. Yes, so all right, now, so there is Keval is asking about what about the logarithms. Keval, we will try and do tomorrow, maybe around 5 p.m. on SE special class. That's app, Unacademy app. So once I fix this particular lecture, I will let you know. I have one assignment to complete. I have something to complete there. I have a little bit, I'm held up in something. So if that gets done, probably I will just take that decision, and I will put this on the app. No lecture on YouTube tomorrow. So those who are doing the geometry module, please continue. We will do that on Friday. And Saturday. Right, so we will go a little bit into thick of this as we progress into Friday and Saturday on YouTube. We will continue our journey with geometry. Meanwhile, every day you guys spend 90 minutes on this. We might, in all likelihood, will be doing logarithms tomorrow at 5 p.m. in all likelihood. If I will put that on the group. Already you are on my group, so I will put that on the group. Take a look at this Telegram group, and you will get to know whether we are doing that particular lecture. Fair enough. All right, that brings us to the end of all the announcements and the things. I hope you guys have enjoyed it. You learned something. If you have enjoyed it, then mark it as you can like that particular one. So you can put it as liked it. So you can like this lecture before you leave, and you can share it with your friends and etc. And that's pretty much about it. Yeah, any questions you guys have, put it. Probably I will wait for a minute. Otherwise, good night. I will see you guys tomorrow or day after. Bye till then. Stay blessed. Yeah. Anything to ask? I will wait for about few seconds. You can post it. Nice guys, thanks you guys for being here. You've been fantastic. You've been really fantastic. Your company, I'm liking your company. It's really good. Yeah, and those who are watching it not online, those who kind of not watching it online, you guys also put it in the offline comments. If the lectures are helping, you can put in the comments so that I can understand. Yeah. Okay. All right. Good night. I'm signing off. Bye-bye. Good night. See you maybe tomorrow or day after. Bye till then.